perfect moment to start recording. I have to tell you that mathematics has several genius moments. I already mentioned that to you before. Let me think. Okay, good. And math majors don't receive Nobel Prizes, if you know. We don't have Nobel Prize. There's a whole gossip about
except occasionally economics.
Yeah, that's why we sometimes pretend to be economics people to get Nobel Prize. But there's a gossip that Nobel found out that his wife cheating with mathematician, and that's why he excluded only one major, math major, from the Nobel Prize.
Wait, that's seriously true?
It's a gossip, yeah. You can find it in Wikipedia. But later.
In 30 minutes after you quickly go to your computer to adjust something?
So we don't have a Nobel Prize, but I will tell you some parts of math deserve a Nobel Prize. And this is the one, and ironically, the beautiful short notation are the one of the genius ideas. This short notation you see here, something that changed mathematics, engineering, biology forever. This short notation, the small equal sign, connects two unconnectable ideas in a very short equation, and I will try to explain you why. Left-hand side is the area below the graph. It's a number, right? It's a definite integral. Definite integral is a number. It's area below the graph, and so on and so on. Right-hand side is antiderivative. We learned it last week. Antiderivative is undoing differentiation. What it has to do with area? It doesn't make sense at all. So this equal sign completely connects two different types of math and iconic ideas in science in general. That you can, instead of using geometry and finding the area of this triangle, you can actually just write down the function, this function, which is a line. This creates the area below the graph, and integrate the equation of the line from A to B. How to integrate the line? Find antiderivative for the line and plug the right endpoint and minus the left endpoint. So, for now, it's a little bit still confusing, so I will give you examples and you will see it makes sense. You don't have to write this down. The idea is find any antiderivative of f, compute f of b minus f of a. So let's do the example. Nothing talks about it more than the example. Example C. This is the most important part of this class. Honestly, we all were doing two important things in this class are learning how to take derivatives and learning how to calculate definite integrals. This is fundamental theorem of calculus. This moment is why you're taking this class. Biology does not exist without integrals or derivatives. Medicine does not exist without derivatives or integrals. Same with engineering, computer science. Coding is built on differentiation and integration for you to know. So that's why you're taking this class. Let's do it. The idea is, instead of what we did before in the previous class, we did sketch the graph. And I'll sketch the graph for you, why not? Sketch the graph and graph whatever was inside. It's a parabola looking like so. And then we told you in last class on Monday, find the area below this parabola from 1 to 3. Oh, so they want me the area from 1 to 3. So this area over here. And to find it, we used some geometry. Remember, there was area of the triangle and trapezoid. So lame. How would you do this one? How would you do this? This area, it's not a triangle, not trapezoid. So people don't use geometry. They just use fundamental theorem of calculus. No need to do any of this. This is extra work. It's not visualization, but it's extra work. But I will point out, this is the area. This integral represents this area below the function y equals x squared above 0, above x-axis from 1 to 3. A is 1, B is 3. So we're going from A to B. Fundamental theorem of calculus says don't do any of this. Step 1, find the antiderivative of x squared. What is the integral of x squared? Almost.
Sorry, I'm back. My brain's on.
X cubed over 3. X cubed over 3. We did learn this before. Add 1, divide. Now, usually we would add plus c and we'll be done. This is what you do for the indefinite integrals. The result of indefinite integral is a function. We even family of functions, shifted up and down by c. Not for the definite integral. The moment 1 and 3 were introduced, the answer should be a finite number. It's the area after all. Area is like 5 meters squared and so on. So the new notation says, put the bar and write down 1 and 3. You don't have to use different color, but for the first time I will show you with different color. 1 and 3. This is international notation. Sometimes you will see a bracket like so, but mostly bar is used. And now the fundamental theorem of calculus says, so you found this antiderivative, plug the right endpoint and subtract plugging the left endpoint. I usually teach it as top minus the bottom. X3 plugged into x3 gives me 3 cubed over 3. Minus is in the formula. Plug the bottom, which is 1 cube over 3. And I usually write down for students, top minus the bottom. Top minus the bottom. Calculate the answer. 3 times 3 times 3 over 3 is 3 squared. 9 minus 1/3, which is common denominator, 26 over 3.
What does this actually represent?
Good question. Let me answer this. So this represents this area below graph of the function y equals x squared above x-axis from 1 to 3. So it should be positive. It is the area. Unless, of course, the area is below x-axis. We learned that one is negative.
We don't use
A number.
units.
What?
We don't use units.
Number. We did use 1 and 3. Those are my limits of integration.
Not like
Limits.
centimeters square or something.
It was because it
Oh, units. You said units. I heard limits. Usually people write down like so. Units squared. Because we don't know which one. Chris. Because we don't know which units, we usually write down unit squared. So this is the interesting idea here. We taking the area. Listen to my explanation. I usually see students like this idea. When you break your leg, you go to get a CAT scan in the hospital, the scan. So, for example, they put you on a table and you're lying like so, and they want to get a CAT scan. What they doing here, they first, for example, do the scan from top to bottom. So the machine keeps scanning me from top to bottom. That is the idea of going from the top of the function to the bottom. So it scanned me like so, but that created a rectangle kind of thing. Now it needs to scan all the hands and sides and stuff. So now it's doing it from right to left. And that's why we're plugging 3 first, and then we're plugging 1. So it's double scan, gives me a precise picture of, I don't know, my lungs and the brain and so on. And then we teach this concept in 3D. And in 3D, the depth shows up. And they scan also depth, and that gives you a 3D picture. So that is the idea. That's why it's integral from to below something and above something. It's below the function, that's my head, above the ground. But then from right to left. It always goes from the bigger to smaller one. Parabola is bigger than 0. 3 is bigger than 1. That is the idea. Questions? What do you think? Then let's practice more. What is the integral from 1 to e of 2 over x dx? Again, the answer should be finite number. If on your homework or the exam you write down a function, you're wrong. The answer should be, let's scan of my body. It has finite size, whatever unit squared, not a function anymore. If there's no limits, it's a function. So if there's no limits, what is the antiderivative of 2 over x?
X plus 2, plus c. 2 over x.
I agree with ln x partially. Then what else? 2 is multiplied, because this is 2 times 1 over x, right? I would say this is in general 2 integrals of 1 over x dx. And then you kind of remember that integral of 1 over x, just like you said, natural log. So it's going to be 2 ln x. Something is missing?
Absolute value.
Absolute value. Plus c will go to indefinite integral. Now remember, it was from what? 1 to e probably, yeah? So it was from 1 to e. From 1 to e, instead of plus c, you put a bar, 1 and e. This bar means at. It's pretty international notation to put a bar that means at. So it's 2 natural logarithms of absolute value x at e minus at 1. You plug the top minus the bottom into your x. It will be 2 ln absolute value of e minus 2 ln absolute value of 1. Here's my e, here's my 1. Those are my limits of integration. Calculate. ln e gives you what? 1. Also, you don't need absolute value anymore. Absolute value is a safety net in case the input is negative. But if it's positive, you can actually write parentheses because e is positive. You're right. Natural log of e is 1. Natural log of 1, 0. So it will be 2. Does that make sense? Some of you are asking, what does it mean? Or maybe thinking to ask. Let me show you. In Wolfram Alpha, as always. So if you want some kind of representation, Wolfram Alpha is doing a good job on that. First of all, I can tell you the secret, which you should be careful with. Wolfram Alpha does integrate stuff for you. Integrate, as you can see, 2 over x from 1 to e. Some instructors hide this information from students because literally it can solve all your homework. Be careful with this. It's nice to check yourself, but don't use it forever because on the exam you cannot use it. As you can see, it gave me the result right away and it showed me what it means. It means the area below 2 over x from 1 to e is 2. So this is how you get 100% on your homework, to be honest. Oh, it was already here. Oh, it's a different one. Yeah. So pretty cool. This is the idea here. Questions? What do you think? Trying to fit. If not, then one more. Here's example number 3. Let's write it down over here. Example number 3. Also integral from 1 to e 4e to the x plus 4 sine y. Like so. Let's start first from finding antiderivative. So for a second you forget it's a definite integral and you just integrate it. 4e to the x gives you...
Or is your sine x? Did you write sine x or sine y?
Sine x.
Sorry, I heard confusing.
What is the integral of 4e to the x? 4e to the x, fantastic. Derivative of e to the x is e to the x, integral of e to the x is e to the x plus c, but c disappears. Actually, in a second I will show you why. What is integral of 4 sine x?
Negative 4 cosine.
So it's definitely cosine, and then you have to think like if it's plus or minus, you differentiate cosine, it gives you minus. That is why you fix it by putting minus in front. Usually that's how people do it.
My brain's good. Actually, my brain got the right answer by going backward.
Backwards. And that's going to be important on the test. You differentiate it or you integrate it. Integral of sine is minus cosine. Now, instead of c, you put a bar from 1 to e. Sometimes students like to put parentheses to indicate that all of this should be calculated at e minus at 1 equals. So let's do it. Now it will be a little bit more complicated, but just your writing should be neat. Make sure that you have a good writing. You plug e everywhere first into the x. E is a number, remember. 4e to the e, why not, is 2.7 blah 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 raised to the 2.7 blah blah blah. Minus 4 cosine of e, why not, it's cosine of the angle 2.7 radians. Now it's important, put parentheses. minus parentheses. This is when you're plugging the top. Now you need to plug the bottom, which is 1. Minus is part of the formula because it's scanning from the right to the left. What is the distance from your dorm to this room? You take the end point, room, minus the location of your dorm. So you always go from the end to the beginning, minus. Plugging 1 gives you 4e to the 1 minus 4 cosine of 1, which is also some kind of number. Closing. Parentheses matter here because without parentheses you will mess up signs. Top minus the bottom. This idea will be important. On Friday we'll do more. On Friday we will do area between graphs. What do you think? Do we agree with this or not really? Looks good, right? So here's the graph. I actually put it in Wolfram Alpha for you before. It gives you the answer, as you can see, which is very convenient. Wolfram Alpha just give you the answer. You can calculate in your calculator, and apparently it's 55.5.
Oh, I see it.
And the area is, this is the graph of this function, which is 4e to the x plus sine x. Below this graph, there's an area, let's call it A, from 1 to E. E is approximately 2.7. That is what we got. We got 55.552 units squared, which is approximately 55.552 units squared. So why we don't write C, by the way, it's kind of interesting idea. When you find antiderivative, you have plus C, and then you plug the top minus the bottom, you will have C minus C. C goes away. And that's why people don't write it down. It is there, but when you plug the top, C at E is still C, so it's going to be plus C, minus plug the bottom, C at 1 is still C. C and C cancels out, and that's why we don't write it down. People kind of remember that thing, that's all. Because antiderivative for definite integrals should be a unique answer. Area is area. There's only one unique area below this graph. So there should be no C at the first place. It should be exact number, not this family of functions anymore. This one, we actually did not study this question, so let me move on. Do any of you know this integral? We actually never studied, so I will skip it. But I'm curious if you know.
I thought we did do negative.
You square it in the denominator.
Would that just be, oh wait, 1 minus?
That is arctangent for you to know. We always teach it to engineers, but we sometimes skip it in other classes. So you don't have to know this one. I did check this class. They skip arctangents, arccosines, and arcsines, which is like a good news. Students always fail these questions. So, honestly. But engineers work with a lot of trigonometric functions, so we push it hard for them. Example, one more example. Integral from minus 1 to 2 of minus x cubed plus 3x minus 1 dx equals.
Is this just a new?
It's a new example. Let's do it. Who wants to tell me the beginning? New topic, and you're already handling it really well. So, you guys at the end with computer. Do you want to tell me? I have a good mood today. Do you want to tell me? Integral of minus x cubed. Anyone knows? No, keep brave. Well, you can tell me too if you want. I can see people like freaking out. In Zoom, it was fun. I could call by names and stuff. It was very convenient. Oh, thank you. Minus x to the 4 over 4. Amazing. Next one. 3x gives you 3x squared over 2. More voices. Who else? Minus 1 gives you x. Minus x. Good, not good. Don't get distracted. Bless you. Instead of plus c, I noticed there are limits of integration. So now we don't tell you find this indefinite or definite integrals. You just see it. There's limits there. It's defined. Defined limits means definite integral. So bar from minus 1 to 2. This is basically explaining, okay, this is antiderivative from 2 to minus 1. Let's see, there's nothing new in this example. Even though it's -1, your job is to be very careful with writing. And that's why if you have neat writing skills, you will be better at this topic. Try to be neat. Plugging the top 2 should be plugged everywhere, saving all the exponents. So put parentheses as many as possible to have no mistakes. 2 is plugged in raised to the 4 over 4. Plus 3, 2 is squared over 2. Put parentheses. Minus 2. These parentheses not necessarily needed, but they will be needed right now. Huge parentheses minus. Minus is part of the formula of the fundamental theorem of calculus. Open new parentheses. This was top. This will be bottom. Plugging x equals -1. This is where you might make a mistake. Let's see why. Unless you put parentheses everywhere. Parentheses are your friends. Remember that. Don't skip them. Minus -1 to the 4 over 4. Plus 3 times -1 squared over 2. Minus parentheses -1. So when we work with negative numbers, that's the algebra reminder, you have to be very careful because -1 to the 4 is not the same thing as -1 to the 4. My American colleague, he's teaching it this way. -1 to the 4 is not the same thing as -1 to the 4. He makes like a dramatic pause. So you should see the difference. Left-hand side is 1, while the right-hand side is -1. Do you remember this? It was lecture 0. I was reminding it in lecture 0. So if you don't put these parentheses, you screw up the whole problem, either over here, or over here, or over here. And even though you did an amazing job, you just screw up because you forgot to put parentheses. So put them everywhere, you know? Not too many. Put everywhere, just in case. Well, that's a joke. Put a decent amount of parentheses.
Parentheses around every single number, you know.
Right? Calculate carefully. Who knows? Well, I actually have the answer.
-9 over 4.
Oh, the first one is 0. The first one seems to be 0. Pretty cool. Because, let's see. -4 plus 6 minus 2. And then the second one is not 0. The second will be minus. And it will be -1/4. Plus 6 over...
That was 3 over 2.
6, oh, I see. 3, go away. Plus 3 over 2.
Plus 1.
And then plus 1. Yeah, that looks good.
That comes out to, that would come out to,
Minus, let's see. Common denominator minus, okay, let me just do it. 2 times 3 is 6, 6 halves, and this one is 4 fourths, 6 quarters, and 4 fourths. 10 minus 1 is 9, right? Minus 9 quarters.
no, it's not minus 9 quarters, plus 9 quarters.
The minus was in front.
Oh, you're right. I missed that.
And this minus is in the formula, so it's always there. So that will be also important part. On the exam, to be honest, I will be checking that you know how to do it. If you make a mistake at the very end, I take 1 or 2 points off, but the process is more important. If I see you found antiderivative correctly, you plug in top minus the bottom correctly, and then you messed up, I'm fine with that. Did you see I gave you some points in the test? Some of you got some points, but maybe. So you have to go and check if you did. One more. How do you feel about this material? A bit boring, but people like it because you can do it. So boring is good because it means you can do it. Okay, let's practice more stuff with stupid square roots and radicals. This is something you guys don't like, so it's nice to practice that. And it is in your homework anyways. What is the area below the graph of square root of x minus 1 from 1 to 4? That is a definite integral of square root of x minus 1 from 1 to 4. Step 1, integrate square root of x. You can rewrite it as x to the 1/2. What is the integral of x to the 1/2? 3/2 over 3/2, exactly. And usually, I also remember, you immediately flip and multiply by 2/3. If you don't know what we just did, it means you're very behind on your homework. You kind of like, if you missed power rule, you cannot do chain rule anymore, right? So this is already a level of it's a level of integration you're supposed to be doing easily. You need to catch up with homework if you don't know what we just did. Minus x, because integral of 1 is x. A bar from 1 to 4, plug the top minus the bottom. Maybe simplify first. If I want to simplify first, I will not plug the top and the bottom. I will keep the bar, and I will simplify my entire derivative first, which is 2/3 x to the 3/2. Also, it will be convenient to write down it as a square root cubed. There's this one I can remind you, lecture 0. X to the n over m is x. Whatever was lower goes to the root. Whatever was higher goes to the power. N was on the top, so it goes up. 3 was on the top, so it stays on the top. Minus x. This will help me because I know what a square root of 4 instead of 3/2. Who knows what is that? Plug the top. 2/3 times a square root of 4 cubed. 4 came from the limits of integration. Minus 4. Parentheses, that was the first part. Minus is part of the formula. Second part is plugging the bottom. That is 1, the lower limits of integration. 2/3 times 1, I'll just write down 1, minus 1. Square root of 1 cubed is still 1, so that's easy. It's nice to plug zeros and ones, those are very nice. Calculate, square root of 4 is 2, 2 times 2 times 2 is 8. 8 times 2 is 16, 16 over 3, 16 over 3 minus 4, create common denominator. Should be 5/3. This is algebra. I'll keep it just behind the curtains. Not too bad?
No, wait, I got 4/3.
Okay, let's check. I really do not want. I definitely agree with 16 over 3 minus 4. 4 is 12 over 3. Minus, if you distribute minus 2/3 and then plus 3/3, which is 1. Let's see. 3 minus 2 is 1. 1 plus 3 is 4. I think it's 4.
Why did you write 13/3?
13/3. 4 times 3, 12. 4 times 3, it should be 12/3 actually.
Oh, I thought you were only calculating. I didn't realize.
4 minus 2 is 2. 2. Yeah, it's 5/3. Yeah.
I thought you were only calculating the first part.
No, everything.
One part at a time.
Everything. So let's do some fun applications then. And fun applications do involve medicine and stuff, and you guys will like it, I think. Yes. Oh, I wanted to ask. Very interesting idea. Very interesting idea. Cool example. Cool example. That should be your favorite example on the exam, but spoiler alert, we don't put it on the exam. Cool example is, what is the integral of x squared sine x minus logarithm of the square root of x from 17 to 17 dx.
That should be 0.
Why do you think so, though?
Because it's going to be the same thing minus the same thing.
Same thing minus the same thing. Do you agree? It's from 17 to 17. If you don't understand why it is 0, which is true, good job, you draw this function. I don't know how it looks like. I can use Wolfram Alpha. And then, this is the function. I don't know. Maybe it looks like that. They ask me to find the area below the function, which is all this kind of stuff. From what to what? From 17 to 17. This is the area of the line. The area of the line is 0 because area of a rectangle is height times base. Base is 0. Height is not 0, but base is 0. So the area is 0. Thus, remember that integral from a to a of any function, no matter how complicated it is 0. That is the pretty cool idea. No matter how complicated it is, there is no area. It's a 0 area. Just for you to know. Thus, if you get 0 as the answer, it's actually an indicator that there is no area there. Applications. As always, you remember we're jumping from acceleration to velocity, from velocity to the position. So, definite integrals will also come from there. Will be used there. Applications. Applications. This is my beautiful Russian A, if you don't know. That's a Russian capital A. Applications. Oh, really? Yeah. So math actually has this A reserved for some functions called capital A. It comes from the Greek letters, but we are taught to do this way. So that's my habit to do. Right? Very nice. And then D, do you know how beautiful our D is? Like so. That's our D. So applications. Chris, are you okay? Doing fine? Good. Integral of, we did it before, definite integral from A to B of the velocity will give you, well, we know it's going to be distance. We're undoing differentiation here. So it's going to be distance, but now it will be distance from the end point to the beginning. So that is not something new. We learned this before, where v of t is velocity. Velocity or speed, it depends on the book. Velocity function. S of t is distance traveled. Distance. Or a position function. Distance, position. Now, this is not the same thing in physics books or applications of math and physics. We explain the difference, but we don't do it here. So S of b minus S of a is total distance traveled or displacement. S of b minus S of a is called displacement. Displacement. Displacement or total distance traveled. Or total distance traveled. From what to traveled? From A to B. From A to B. And I did, while you're writing, I will remind you, I did it before. So I explained it before. When I'm walking from here to this table, when I'm walking this direction, that is distance. Distance between tables is this 3 meters, I guess. And then, what if I just walked halfway through, then I said to come back a little bit, and then I walked a little bit more. The displacement will be not the total I walked, because I walked a lot. Displacement will be made from here to here. It's a difference from the beginning to the end, regardless how many times I actually was going back and forth. So that's what's called displacement. It kind of makes sense, displacing something. And then, more generally, we have also integral of rate of change. So in general, let's put it in the rainbow box. General. In general case, integral from A to B of any rate of change. Rate of change. Of any rate of change of f dx of capital F. Rate of change is derivative. That's what I told you many times. That should be your trigger or synonym of the derivative. Is going to be F plug the top minus F plug the bottom, which is basically total change in F from A to B. Total change in F from A to B. And that is what's so amazing about the fundamental theorem of calculus, because it's not just kind of stupid areas. Who cares about areas below x squared? This is something that we can actually undo when we see the spread of the bacteria on a surface. It's already derivative. By finding the integral, we can see total change of the bacteria amount, population of the amount of the bacteria from this time to this time. Or you can see how the tree is growing. That is a derivative. The total change of the height of the tree will be from this time to this time, and so on. So that is the amazing idea. Let's do this last example over here. For today, it should be good enough. And you'll see these examples on your exam and in your homework, application examples. Suppose, and these are the most interesting ones. Suppose a population a population is growing. That is derivative. Whatever is changing, immediately you should see, oh, it's probably derivative of something at a rate. Also, since it's growing, it's a positive derivative, right? Increasing. At the rate. Rate is also a synonym of the derivative. The derivative is given p prime of t, population is usually denoted by p, equals 2, 0, 0, 0, e raised to the 0.12t. Now you know even small rate in the exponential function might mean a lot. Even 0.12 might mean a very high exponential growth. That is exponential growing function, where t is time in minutes. No, that was months. I did not see. It's a little bit larger than minutes. Months. In months. Population is growing in months. So I guess it's a population of actually some animals, not bacteria like I thought. How much did the population grew between 0 and 4? Question 1. How much did the population grow from t equals 0 to t equals 4? So for example, we started looking at this process in January, that is 0, January, February, March, and April. In April, we want to see the difference. Usually we start, before we learn integration, we were doing the same problem the other way around. I told you, you come back in 4 months and you collect the data. Now you have 2 data points and you find derivative from that. Now we do the other way around. We know the derivative. How from knowing derivative we can find what was the change from January to March? You integrate solution to undo the growth and define actual change of the function. You do integration, and this is a definite integral from 0 to 4 of the given derivative of the population with respect to time t, looking like that. Moreover, the fundamental theorem of calculus. So before fundamental theorem of calculus, you did not know how to solve this. By fundamental theorem of calculus, now you know. You need to find antiderivative, bless you, which is population, plug 4 months, fourth month, minus same antiderivative, plug 0 months. That will be total change in population. That will be a total change in population. So let's do that. So this was introduced by the fundamental theorem of calculus. Before this, we do not know how to solve it. That's why it's so beautiful. So let's rewrite again. Integral from 0 to 4, p prime was given as 2000 e raised to the 0.12t. See, it's growing exponential function because it's not negative, doesn't have a negative rate. dt. Now you have to integrate this carefully. Who is brave enough to do that? Because you're always brave enough, but I kind of want anyone else to be brave. Yes?
You copy it and then change all the 0.12.
Exactly, good job. You copy it. Exponential function, differentiate or integrate. The first step, you copy exponential function. But then you notice there's a function inside. When you differentiate, you multiply by 0.12. But when you integrate, just like you said, you divide by it. Amazing. 0.12. What happens with 2000?
It stays.
It will stay because it's multiplied. So this is my answer. Do you guys agree, disagree, want to add anything? I think it looks amazing. Bar, instead of plus c, it's from 0 to 4. So we're going to plug, let's put equal sign. Top minus the bottom. 2000, I would divide by 0.12 right away, so you don't have to be bothered. Some people even factor out and see it like so, to be honest, if you want to. But not to mess up your understanding right now. I will not do it because it's a new material. E raised to the 0.12 times 4. You see 4 shows up at the exponent where t is. Plugging 4 and plugging 0. Minus is part of the formula. Minus 2000 over 0.12. Let's show up from undoing chain rule. E to the 0.12 times 0. Be careful, many students, and I will put parentheses everywhere. Many students immediately assume that the second term is 0. Is it true? No, e to the 0 is not 0. Many people freak out during the test and give me 0 over here. And I have to take points off. The second term is not 0. E to the 0 is 1. So we're ending up with 2000 over 0.12. That's a big number, by the way. If you're dividing by a small number, you get a big number. E raised to the 0.48, right? I just multiplied 4 by 0.12. Minus 2000 over 0.12 times 1, which is, let's see, 10267.9 approximately. So this is the exact answer. I would factor out this awkward number, and the way usually in the literature they show it this way. What is 2000 over 0.12? Can anyone calculate? And then people factoring out this number. What is 2000 over 0.12? Anyone? Yes. Chris, like such a rare case, I really needed you to defend.
Actually, I can get that.
2000. How many? 6?
16 or
146.
146 and then 6 repeating.
Yeah.
Oh, it's a product though. Oh, really? Okay.
Or 16,666.6 repeating.
Okay, then if it's not exact, then let's keep it like so. That's actually better then. So this is the exact answer which mathematicians like. And then life sciences. So they want to have some kind of feeling of what is this number represent. This number represents population. So it's nice to know how big it is. Apparently it's 10,000 something something, and since it's population, we should not have half of the rabbit or 9 point something of the fish. So let's round it up or down? Up. 268. Mathematically we're rounding up, but actually in life sciences sometimes they round down because 0.9 of the rabbit should be excluded completely. So be careful with this. That depends on the book and the lab you're working in. This is the population that changed, let's see the question, from 0 to 4. That is the idea. And now the question B, we can plug anything in and find whatever happened there. But do you guys have questions about this? Is it doable? This is your homework. It will be the most pleasant homework from the whole semester. Just like basic derivatives, you will like it. Good job. There is class on Friday. Don't forget to come.